This conference will now be recorded.
Sir, we were doing schemas, no, sir.
Sorry, that is the next batch, right? Okay, we were working on the schema. I thought I'm taking it for the 9 a.m. batch. Okay, Z1 yes. So OWP I explained last session. Okay, next waste type operation. So how to use it? Next operation, waste type operation, guys. Look at this. I have 100 waste types. Okay, 100 waste types. In that, 70 of them added to, let's say, 1A01. 20 of them added to 1A02. Or same, this is 50% అనుకుందాం, added to 1A01. 25% added to 1A02. Remaining 10 not relevant in this calculation. Totally 100 waste types in input table. Totally 100 waste types in input table. Okay, 70 of them added to 1A01. 25% added to 1A01. 20 waste types. 25% only added to 1A01. Remaining 10 waste types not relevant. The question is, how do you write this rule? Is it a generic rule or waste type specific rule? Is it a generic rule or a waste type specific rule? Anyone?
Sir, it's a waste type specific, sir. If generic means all the waste types, right?
Sir, it is a generic, sir.
So if you write generic, how do you apply that rule? How do you write this calculation? Tell me. How do you write these calculations? Anyone?
Sir, first we have to write the rule for output table. Add waste type. ADDWT 1A01.
AWT star. Why 1A01? Only 50% of its amount. 70 waste types amount should be added to 1A01. 20% of 25% added to 20 waste types. 10 not added. How do you write? Would you apply amount 50% or amount 25%? What do you write? Hmm?
Sir, amount 50%, right?
Hmm. Is it what I said?
Amount percent 50. Yes, sir. And waste.
If I write it like this, am I not applying this rule for all 100 waste steps?
Yes.
Yes, sir.
Is that correct? Is this
No, sir.
what I said here?
Sir, this is for generic, sir, not waste type specific.
That's what I'm saying. We have written generic only. Is it correct? Generic way.
No, sir. We have to specify waste types. No, sir. We have to split waste types.
It has to be waste type specific. How many waste types do we need to call in the rule now?
70 for first one.
My question is, how many total waste types do I need to call in the rule at a second
Total
level?
100, sir.
Anyone else?
Total 90, sir.
Total 90 waste types you need to call. Okay, let's say one is 1B01, 1B02, 1B90.
Can't we define the range, sir, from 1 to 90
You
like
tell
that?
me if you have any idea how to define a range. I did not give you any operations so far on ranges.
No, actually,
Look,
it is too much manual work. No? That's why. Is there any option I'm asking?
and that's what I'm going to tell you about. Okay.
Okay.
So we have 90 waste types here. Okay. Calling a 90 waste types is not a right practice. Again, if you look at 90 waste types, 70 waste types we are applying the same operation. Okay, same operations. What is that operation? Add waste type to output table, and then amount percentage 50, and then add waste type to 1801. We are applying this rule for 70 waste types, and we are applying this rule for 20 waste types. Two processings for 90 waste types, and you are calling 90 waste types here, and it is not possible without calling a 90 waste types in the second level, because when I say all 90 waste types have one calculation, 10 have one calculation, okay, you still need to call 90 waste types, because all the waste types in the all 100 waste types are not having a same rule applicable. So as long as the waste types, all the waste types are not having a same logic in the rule, the rule has to be a waste type specific rule. When I say all 100 waste types, see, all 100 waste types, apply amount 25%, and then add to 1801. How do you write it? You can write it simple, generic rule. Okay, then you simply write it like this. Okay, now I said only 90 waste types, not 100. But input table I have 100 waste types. 90 waste types are relevant in this calculation. Can you write generic? No, you have to call 90 waste types. Okay, call 90 waste types, write this logic for every waste type. Write this logic for every waste type. That's where we can make use of waste type operation. The waste type operation is useful in such a scenarios. For example, let's take this example. I have 100 waste types in the input table. 90 waste types I need to apply this rule. 90 waste types I need to apply this rule. What I would do is I call generic rule. I can call generic, okay, at a second level. But in the third level, I have a decision operation. Query on the name of the waste type. Query on the current processed waste type name. What I would do here, I would call 1A91, 1A92, okay, 1A91, 92, like this 1A99. These waste types, we don't do anything but moving to output table. Okay, totally 10 waste types I called here. If it is a decision operation, there should be otherwise, right? Now, otherwise represents how many waste types? Otherwise represents how many waste types?
Other 80, other 90.
80.
90, sir.
The other 90 waste types. Let's say this is 1B series, this only. My result waste type is 1A. If any one of these 10, it goes here. Otherwise, it goes here. I may not call both here otherwise, but I can call otherwise when I use a waste type operation. Operations can have otherwise conditions. So let me show you the same example now. What is your employee ID? Do you remember, guys? Which is the one we are testing? This one or above one? This one. We have 2B series here, of course. Okay. Now what I would do is only 2B series I want to call, not anything else. Okay, only 2B series. So here, let's assume I have 2B series. In this example, why so many splits are there? To keep it simple. I'm trying to remove the splits to keep it with only 2 or 1 splits possible. Okay, let it be. Now look at this. How do I write this rule? Go to PE02. WGTYP operation. Don't keep star, but see. Okay. I call generic. Then I query on the name of the waste type using waste type operation. Okay. Using waste type operation. If it is 2B01, 2B02, 2B03, we apply one calculation. All other we apply one calculation. If it is 2B01, then I can call move the waste type to output table, amount percentage 25, and move to 1A01. Now look at this. Isn't it useful? Okay. So in this method, if this is the requirement, if this is my requirement, then I can end up it in writing 11 entries. Okay. 11 entries. My requirement is this. I have 100 waste steps in input table. I have 100 waste steps in input table. Only 90 waste types. 90 waste steps only added to 1A01. So what I have taken here, the remaining 10 waste types I call directly under waste type operation, and then I kept ADWT start. Other than this 10 goes where 4 starts. Other than this 10 goes to 4 starts. Then in that case, I can move this waste type to the, I can apply this rule under 4 stars. Am I correct? So totally 11 entries you will have here. 10 waste types plus otherwise, and otherwise represents 90 waste types. Is this point clear to all of you?
Sir, according to our query, 70 waste type, 50% to be added to A1.
This waste type,
One is
this example, talk about this example.
okay. Then it's correct, sir.
Okay, next. Going back to our calculation. This one, how do you write? Which is the best way of writing it? Anyone? And all my waste types, these are, let's say, 1A012, 1A70, 1B012, 1B70. These are waste types. Okay, this is 1B71 1B90. Okay, these 10 waste types are 1B91 to 1B99. or 1B98 this one, 99 this one. Okay. How do you write this rule now? How do you write this rule? Anyone?
Sir, hello, hello,
Yes.
sir. First, we have to write the 10 waste types 1B91 to 1B99.
Hmm.
For not adding. Next, after that, 1B01 to 1B70 with 50% amount, you have to add to 1A01. And
Hmm.
from 1B71 to 1B90, you have to give 25%.
Hmm. So if you are writing, what is the difference here? Calling the specific waste types and calling, anyway, you are calling all 100 waste types here. Then why it has to be generic? What difference does it make? I'm telling you, using a waste type operation, how do you write this rule? And the rule has to be as simple as possible. Anyone? Query on the name of the waste type. Query on the name of the waste types. I will call 1B91 to 1B99. And I would say, just move the waste type to output table. Don't do anything. 10 waste types I called. Then I will call 1B71 to 1B90. Yeah. For this, I would say AWT start, and then amount percentage 25, and move the waste type to output table. 1A01. Okay. For this 20 waste types, you will get this rule. All remaining I keep 4 stars. So how many entries under waste type operation you have? How many entries under waste type operation totally?
30, sir.
31.
31.
31.
You can complete this rule with the 31 entries. You can complete this rule with the 31 entries. Clear? Okay. Now, okay. ఇలా ఉన్నాయి with the different names. How do you write it now? Same thing, no difference. With the operations that I have explained, it's the same thing. Okay. So here you call 1C01, 1D012, 1D10 individually, and 1C012, 1C20. Now 1B series will go here. But the waste type operation can be more useful if you follow a naming for the waste types here. There is a sequence followed here, naming sequence followed. Okay. If you see, instead of querying on the 4 digits of the waste type operation, You can query on the first 2 digits of base step operation. If you remember in features, we have an option to reduce here. When we call addition operation, not here, for example this one, when we call addition operation, calling the first 2 digits of the personal area field comparison, you select personal area. Generally by default it's a 4 digits, and I want to query on only first 2 digits. What do? Setting a variable key length to 2 digits only. First 2 digits only will be considered, right? So this is the feature we have. This is the kind of option we have in the features. Similarly here, okay, I keep this rule as it is. I write another one. Okay, now observe this. First to use operation VA. Intra. VALEN. This is your new operation I'm telling you now. Set a variable key length to 2 digits. Set a variable key length to 2 digits. Whatever is the next addition operation. For whatever is the next addition operation, set a variable key length to 2 digits. It can be OETWP, VARST, it can be waste type operation, any addition operation. If you use VLEN, it counts only first 2 digits. It doesn't count the remaining 2 digits. Okay, so I have a 2B series and star star. 2C, for example, I have 2C also, and I have a 2D also. Okay, only 2 digits. Now move the waste type to output table. Okay, I can write the conditions like this. Okay, now verify it, how it works. Now look at this, guys. I have all 2B series. Now see how this rule is executed. I should give GEN. If I'm using a waste type operation, that I should give GEN. We are calling all generic waste types only. And every waste type in the rule. See, I have all to be series going to be only. Now with this, I can complete this line rule with just a 4 lines. It's possible only when this naming is followed. If naming is not followed, how would you do it? This is a way. Calling a full waste type name and making use otherwise condition. Is that clear to all of you?
Yes, sir.
Okay. So take this screenshot and practice this for today. And the reason for telling you this is tomorrow we are going to cover a processing class. This is the base for the processing class. When you have a processing class, without having naming for the waste type, let's say the 4-digit code of waste type from any number or any character, the processing class will help us to keep the rule even simple than this. So this is kind of introduction of the processing class. We will see the simple advantage of a processing class tomorrow. Okay, take this screenshot and practice it, guys.
Sir,
Tell me.
sir, can you share the video of Saturday's session, sir? Indian payroll on today's.
Oh, well, I'll share this video also. Listen to this video once again. It's very important. See you tomorrow, guys.
Sure, sir. Thank you.